Hello, I'm Robert, and welcome to my channel, where I talk about everything automated algorithmic trading, or simply algo trading. In this video, I'm going to recap the last program we did and talk about what it did right and what it does wrong. Then I'm going to introduce the fixes to what it does wrong. The program itself worked very well, but there are some critical points that we really need to focus on and look at. So let's get straight into it, and we have the program on the screen. Let's get down to the most important part of the program, the main. This program runs efficiently and does a good job at what it's supposed to do. But we have several major problems that really are just one big problem that we need to look at. This is kind of a double-edged sword, though. It's a problem in one way, but in another way, it could be considered a benefit. And that is, every time we do something, it creates a new list. Now we have 3 lists already, and all we've done is calculate 2 moving averages. Once we start adding more indicators, like Bollinger's, or RSI, or any of the other ones, this is going to get out of hand. If we have 3 lists just in calculating a moving average, what's going to happen when we start calculating the combinations, like Bollinger's versus a momentum, or using the 200 period moving average with MACD RSI? You can see how this is just going to wreck memory and at some point become non-efficient. The other problem is, what if we want to compare 2 different time frames, like the 1 hour and the 5 minute, and then you want to run the exact same analysis between both of them? That becomes even more exacerbated and a nightmare the way this is set up. So while this works wonderful for a one-trick pony, moving past the point of being able to really examine and look at the code in a meaningful, reusable, sustainable way is a major problem we need to address. And the way we address that problem in Python is we use a class or an object. And that is exactly what this video is going to be about. Taking this program that is non-class based and actually making it into a class-based program that will eventually become an indicator library. So now that we've gone through that, let's actually get to the class-based program and really talk about that. So far everything's the same. I've added some nice comments to the beginning of the class, but here it is. Here is our class. And this class does some very important things that we're going to talk about. Most importantly and most critically, instead of having 3, 4, or 5 different lists as a part of the analysis, the class lets us take one list, and rather than making a new list every time, it simply adds the information to the original list. So it becomes more efficient memory-wise and more efficient speed-wise, because we now have a way of simply keeping one list for all of our work. So let's talk about this part of it. This is the initialization part. This is what you actually communicate with once you use the class. And because we're using Jackrabbit Relay to run it, the class needs to be able to actually invoke relay and store the information inside its own framework. So this class lets us do analysis without actually directly working with relay. It will do it for us. But it provides all of the basic functionalities we are going to need for relay to work correctly. It also adds another element that is critical if you want to work between cryptocurrencies and the Forex markets simultaneously, and that is the precision of your numbers. Cryptocurrency numbers are 8 digits behind the decimal, but Forex is only 5 digits behind the decimal. So we need a way of being able to limit our numbers according to what we are working on for the market we are working in. So we see here that we are force loading Jackrabbit Relay. In other words, instead of relay going out on the command line and searching for whatever elements it's looking for, we are explicitly telling it what it is going to do. We are setting up a framework by which it is given information that it will then go and look into your configuration file and get the framework, your key, your API, and all the other relevant information that the program needs to communicate with your exchange efficiently. And we are adding a bit of a sanity test. This is an interesting little approach. If the end user gives the program a time frame that the exchange or broker doesn't understand or doesn't trade, then this puts out a list telling that user that they need to pick a time frame that the broker actually does use. So this is a nice little way of actually making sure that you get a proper time frame before you start actually communicating with your broker. It's a simple approach, but it's very effective. And let's see how that actually looks. Okay, let's give it a time frame. We know it doesn't trade. And you can see it recognized that a 17-second time frame is not something it trades, but instead it gives us a complete list of all time frames from the 5-second to the 1 month. Everything that you can actually trade on this particular broker. So it's a nice little way of making sure you get the proper information. And then of course it just exits out to the prompt. Now here is something we do at the end of the class initialization process. We want the class to automatically go and get historical data. The whole point of this analysis is to read the historical data. So by having the class do it for us, then we can just get straight into the analysis part when we get that far. And of course, you see the traditional customary help reference, just a blank simple process that's used right here in the usage mechanism. Just a nice little way of keeping the program running even in the worst case situation. Now for the historical data, all it does is just make sure that it gets the OHLCV data the way we want it, and then it returns only the historical count. The last live candle is taken off the list. Now, these self-references, these point to the class itself. All of these variables up here, these are important. This is how the class is able to communicate within itself, as the int function is basically the initializer. It controls everything within the class. Remember from the original Learning Python series I did, I talked about very simple classes this way, and now we are actually beginning to see a real-world circumstance of how that works on a larger scale. The examples I demonstrated in the crash course version were very simplistic. Here you can really see that simplicity taken to a new practical level. So now that we have that, and we have the historical data done automatically, now we see our SMA function, where this has been rewritten from the original. You can see that it now refers to the existing OHLCV list. And instead of creating a new list, it simply takes each row of the original list and adds the new information. So instead of using up memory through list after list after list, our original list is simply being augmented as we need to. And we do the same thing with the crossover, cross-under. A very simple, crude approach, or so it seems to be, but it's really not. This efficiently manages your list. It efficiently lets you be able to build on what you have in such a way that you're able to extend it and develop bigger and more complex ideas. And here, I want to draw this to a special point. The class requires all self-references for every single element that accepts parameters. That is, when you talk to a function within a class, it needs to reference its own data points. So that's what this does. And then, of course, what we saw in the previous version, column 1, column 2 of the list we gave it. Now this is just a general diagnostics that simply prints the list. Short, sweet, to the point, and when you want to see what's going on, it just does it. Now let's get into the changes for the main code. Here we see I do my own housekeeping. Relay doesn't check the parameters anymore directly, even though it will do its own diagnostics when it gets called within the class initialization. I take that responsibility here. I save all of the variables that I want to use. This is important because when Relay gets to this point, it will eat the command line. Very important. So anything you want on the command line saved, do it before you call the relay command. And here is where we initialize the class, and the class initializes and calls relay. So in essence, we have a process that does both. And we set the default to 8 positions. Now we can set the default to 5 positions, but I wanted to demonstrate this so you would see how it can be done right through the analysis stage. And then, instead of collecting the historical data like we did previously, we jump straight into calculating the first simple moving average, because the class has already collected the historical data for us. Then we calculate the second moving average, which is the 200 period. And in both cases, both of these are using the closing data. And now we calculate the crossover. Crossover, cross under. We want to know when the fast moving average, the 20 period, crosses over and under the slow moving average, the 200 period. This is literally all we need now to handle the entire basic blueprint analysis of our data collection. Now, the rest of the program really just goes through and breaks down the information to display it. So we now take the actual OHLCV list that we created from the class and we find out how many data points we have. Then we create the current row variable. And now from the last version, we take the millisecond time and convert it into a string. And now we simply display all of the numbers that are not a Boolean. Short, sweet, and simple. Nothing over the top here so far. And now we check to see if we are a crossover or cross-under. Remember that column 8 is either negative or positive depending upon what series 1 minus series 2 gives for the current row. So if the number is negative, then the moving average, the fast line, is under or lower than the slow line. If the number is positive, then the fast line is above the slow line. So we can use this information to test for crossover and cross under. And now we go through and we do just that. We check for crossover and cross under. Now, crossover and cross under requires two candles, the current and the previous. So that is why we need the index to be greater than 0. We have to have two candles. We also need to have the OHLCV data for the index, the plus or minus to be not equal to none, meaning we have to have already have and passed 200 points of data, since that is our longest simple moving average that we are analyzing. So by the time we get to this information where we have either a positive or a negative number, we have already covered 200 candles in our list. Now we take the previous row. We need to analyze the previous row. And if the index is 0, we don't have a previous row. So you can see here that we're using index -1 to get the previous row. It's a nice little shorthand way of doing it. But if we get, for example, if the current row is not none, we still need to check to make sure the previous row is not none, because we could be exactly at candle 201 in our list, where we have the current row information, but we don't have the previous row information. So now that we have previous row, we look at whether or not the current row is greater than 0 and the previous row is less than 0. If so, then we have a crossover. Likewise, if the current row is less than 0 and the previous row is greater than 0, then we have a cross under. And in the event that something goes wrong, meaning it's neither a crossover or a cross under, we just want to display a space. We want to keep our table nice and pretty looking. And here, in the event that the previous row is none, same thing, we just want to keep the spacing nice and neat in the table. And here, in the event that the index is 0, or that we have not yet gotten a list, meaning something went wrong, this one just, again, formats the table. Now that we have everything, we simply print out our nice, neat little string that we've built. So let's see how this looks. Here we go. And as you'll see, it looks pretty much identical to what we saw yesterday. We have the time, open, high, low, close, volume. And then we have the first 20 period moving average. The blank spaces above it are where it doesn't have 20 points to analyze. Now we're going to press over, and then we're going to go down until we get the 200 period moving average. Okay, so here, 200 period moving average, we've got it done. And we know we have our current situation is the fast line is less than or lower than the slow line. So we are a little symbol, the less than sign, that shows us that. And we have the distance of 0.00014 pips. So we have a system and framework literally of what we had yesterday, but significantly more efficient that we can begin expanding on and growing. So let's keep going, and let's see when we get to the crossover. Whoops. Okay, we have the crossover. And we see the actual crossing. And now something to be aware of when you're looking at the difference between a slow line and a fast line. We can actually see how they come together numerically. That is, we can see the numbers or the spread between a slow line and a fast line get smaller. We can actually use that for our swing low, swing high approach that we'll be discussing next. We can actually track and test how we come down the candle, hit that bottom part, and then begin going up, so that we can begin building our entry point information with this data. But overall, you see realistically how this works. So now let's look at the next candle. We see it's over, and we see the distance begins to increase. So we now see that once we've crossed over, we see the fast line going up over the slow line. And let's see if we can find out when it bows back down. And still going up. Still increasing. Okay, right here. Here is the point, the last row. This is where we reach the apex of the fast line going up. Now it's leveling off, and now it looks to be slowly decreasing. So now it's losing that pressure and beginning to drop, going down towards the fast line again. So once we've reached the top of that bow, we sell, and we've captured the market. And now we follow it back down. Now it could turn around and go back up, and that's where we get out, we'll get back in, and then we'll go back up with it. That is the swing low, swing high methodology. And that's exactly what it did. As we are now climbing again. But it didn't meet the criteria of the swing low. And we'll see what that is in the next video when we actually start looking at the swing low mechanical process. And you want to explicitly look for that very exact pattern that creates, because it gives you a bit of a confirmation that the market is poised to go in the opposite direction. As you can see here, this kind of just keeps going. But then it rapidly decreases, and we now cross back under. So up, over, under, crossing, and now we start going towards the bottom. The numbers will increase. Let's see where the numbers increased at. Okay, the swing low part hit right here for the apex. This was the lowest part of the apex. And then it starts moving back up towards the slow line until it crosses over. So you see just how efficient this technique can be in analyzing the market. But because we're building this in place, only using one list, when we start moving to Bollinger's, RSI, or any of the other indicators we want to use, we have a principle framework that we can build on and maintain efficiency as much as possible. But there's more to it than that. As I said, what if we wanted to analyze the 1 hour time frame? Well, we can, because we can actually use this simple format just by changing the time frame and changing the variable names. So here, I'm just going to do a quick hack, but it gets the point across. And I'm going to change this directly and force feed it. So now I have the original time frame, which is at 5 seconds based upon the command line, and the 1 hour time frame, and they're both separate. But the thing of it is by doing this way, I don't have to stay on the same exchange. In the case of two cryptocurrency exchanges, I can use the very same approach for Femex and KuCoin, for Binance and BitGet, or any supported framework within Jackrabbit Relay. And I can actually take and develop arbitrages, I can develop cross-correlatives. All sorts of things can be done and developed using this technique that isn't possible without the object-oriented layer. That is the class functionality. And I can access both sets of information side by side just by the variable itself. So I can take, for example, if I want to see a momentum on the 1 hour, well, I now have that. I can now compare the 1 hour momentum to the 5 second momentum. And I can actually stack them in order and see how that works as a bigger picture assessment. So now I have multiple time frame analysis, multiple asset analysis, and multiple exchange analysis, all within one simple framework, within one simple layer. And that really is how we are going to build this process as we continue. We are going to add more and more to it, building on this until the point that we eventually have a full, complete, and robust indicator library that we know how it works. We also have a way of capturing situations that you can't in the pre-made libraries that exist on the market. Meaning, you now have a tool to help you find your edge because you have the resources necessary that give you the ability to analyze a market in a different way, with a different point of view and a different perspective. So there you have it. That's really all there is to this program. It is literally just a rewrite of what we had yesterday, but significantly more efficient. So if you like this video, give it a thumbs up. Hit that like button. Help the channel grow and help me get more information out there. Leave a comment. Let me know what you think. Ask questions. If you have a question, ask it. There is no such thing as a stupid question when you are learning. And all too often, if you don't get the basics down now, you'll have difficulty understanding the more complex approaches later. So get those questions out there. Put them in the comments. Use the support server. Use the Jackrabbit Relay ticket system and put it there. Let me know if you have questions. If you're not subscribed, please subscribe to the channel because it helps me. Thank you for watching. And until next time.